The issue is the problem of public servant. So they get no incentive when they do well, but if they do a mistake, everybody will blame them. So why should they take risks? They operate in a very strict and firm regulatory framework that doesn't give you a lot of flexibility, but some of the changers in those organizations are taking this risk and pushing back. So Italy is moving, the direction is very good.
Hey SpaceWatchers, and welcome to our Space Cafe. Today we are here at the World Space Business Week in Paris, and I have the great pleasure just being off stage with Dr. Luca Rossettini, the CEO and founder of the Orbit. And Luca is now with me, and it's an absolute fantastic moment because we just talked about his story of the Orbit and how he survived all of that. Luca, welcome to Space Cafe Radio. How are you doing today?
Thank you. Thank you for having me here. It's a real pleasure. We know each other since basically forever, so it's a real pleasure. Very good. Yeah, thank you.
Great. So tell our audience, the Orbit is often described as a pioneer in the in-orbit economy. How would you explain your missions and the value you bring to the market in just a few words? And I know that's a hard part for an Italian.
Yeah. First of all, let's say we believe that if the space economy will expand at interplanetary level, at that point, you will need an infrastructure capable of transporting goods, people, information, and energy. Otherwise, no business will be successful. It's basically the same on Earth. And we want to build that infrastructure. So to support any business that is currently running, but also the future business and business models that will be invented in the future.
How do you pivot your company over the last years from really coming from the Orbit devices now to an, I would say, full in-service supplier? I'm not sure what the right wording is you use.
Yeah, I'm not sure if, because pivoting is considered like a good thing. So I'm not sure if I can be considered a company that actually was able to pivot. So we followed a strategic roadmap towards this vision. And the first step, by the way, didn't go as expected, but the first step was to start building all the technologies that I would need in the following steps. And it ended up in a product. It was a decommissioning device. But as I was saying before during the panel, I only sold 3 in the entire life of the company. So it was not a good move, too early. The market was not there. But that allowed me to build satellites, starting from small satellites. And then at that point, I had the capabilities of building bigger satellites and so on. So every time that we move, it's like now, right? So we start with satellites without the cloud computing capabilities because we didn't have that knowledge. And now every time we fly an Ion, it's becoming a node of a cloud computing network in orbit. And now we are moving to the in-orbit servicing. So it's always step by step. It's not really pivoting in my view. It's understanding that the market is coming. Sometimes it's too early and sometimes we are okay. Like the in-orbit servicing, we are not the first. We didn't invent the market while we invented the market of transportation and cloud. So you have to feel the wind.
Oh, absolutely. I would like to stay on our orbital transportation and constellation front. So you have been at the forefront with the Ion satellite carrier. So how is this shaping constellation development, constellation deployment, and benefiting operators in terms of cost, flexibility, and optimization?
Yeah, so the concept is pretty similar to the logistics on Earth, right? So why do we need logistics? Because we want to reach a certain place in the shortest time possible, because time is money. And for constellations, it's even more important because nowadays satellites are not lasting 15, 20 years in orbit. They are cheap, and especially these companies need to show profitability as soon as possible because they are burning money. They send a constellation in orbit without a logistics service, then you will find all your satellites packed in one orbit only. And maybe that orbit is not the best. But you compromise. Say, yes, it's okay. It's going to take 8 months to get the full deployment around the Earth. And then from 8 months to 3 years, 5 years of life, I make money. But that 8 months, it's a delayed, but also revenue lost. What if I can bring you there in 1 week, 2 weeks, 1 month? Even in other orbits, or maybe the precise orbit that is perfect for you. That's the advantage of logistics. And it's not just reaching a place that is not reachable with rockets, but it's also fast deployment of a constellation that it's ready to serve the market of the customer.
Let's talk about let's call it the rise of in-orbit servicing, because that's a term that is still relatively new. The idea is not new, but the deployment is relatively new. In my opinion, it's emerging fast because there's also a strategically geopolitical component in that. How do you see this market evolving, and what is the orbit's role through initiatives like the Rise mission, for instance, in that?
So that it's going to be way more than what it is today. So everybody thinks in orbit servicing, oh, you go after satellite, you extend the life or you remove it at the end. But actually, again, so what in orbit servicing is going to become, it's a real infrastructure of service at 360 degrees. So today, yes, what is the market today? Today, the market is in GEO and satellites that need to stay as much as possible because the market in GEO is declining. So if you have an asset, you want to use it as much as possible. So that's where the market is today. Life extension, number one. And then, of course, the commissioning because you want to free the slot, right? But then once you have these capabilities, of course, then you go to LEO. But then tomorrow, you can use the same vehicles to collect the debris, to bring them in a recycling station in orbit to produce raw material that is going to be used to produce new satellites. You have a circular economy, a closed loop in orbit. That's where we need to get. We don't build boats on the desert and move them into the sea. We build them on the harbor. So why should we build satellites on Earth if we have to use it in space? But we need the infrastructure that is not just the orbital manufacturing. So how you bring stuff to the orbital manufacturing facility?
How far are we away from the scenario that you just described?
Yeah, that's another element. So I'm always an optimist. Probably the numbers I'm giving to you are wrong. But if I see how fast is moving the trend, probably in 10 years, we will start seeing something concrete. Probably not the fully developed market, but it's going to be there.
Hey, we want to be 2026 as humanity on Mars. At least it was in the books at one stage. You mentioned one word that I want to explore a bit more, and that was space cloud computing. Processing data in orbit, it could be transformative, sure. But how will space cloud computing change service delivery for operators, and what immediate use cases do you see gaining traction?
Even in this case, it's a new market, right? So not even the customers understand immediately what is the value for them. So you need to go through the usability. So you need to test with your own hands. So Excel files, PowerPoint, simulations are not useful. We divide the customers in 3 categories, and they are probably sequential. Let's see, now they are a little bit overlapping. But the first one, it's the companies on ground, on Earth, not space companies, they use satellite services. So imagine a remote, oil and gas platform in the middle of the ocean. When that platform has an issue, what they do, they send an alert signal through satellites, going the mainland. The mainland download images of that area. They process with their own AI machine learning algorithm. Then they send the solution back. This is taking 4 to 8 hours, up to 4 days. Long time. What if you have a satellite at the horizon? You send the alert. The satellite collect the information without downloading to ground, process the information already in orbit using the entire network of satellites. And by the time that satellite or the next, it's at the end of the horizon, then you have the information. So it's almost like real-time answer.
So it's a distributed data center in space.
Yes. So we demonstrated that you can reduce by 98% the amount of data that you typically need to download to get exactly the same information. So you have 2 cases, like commercial makes more revenues. Civil, it's actually, you save life. And then there is, of course, the defense case, right? Because you can send machine to machine. You don't need to tell the people where to go. You go directly to the car or to the machine or to the tank or to the tractor that need to put water on the field. You send the GPS coordinate and they go there, or actually the Galileo coordinate now.
I think that's also an interesting concept that we know from Earth. Both of us are old enough that we're born into the world of computers. And it started with a mainframe, then it went to the edges, and now back to networks. So it's like breathing on a decade cycle. And that's what I have the feeling in space as well. We started with this CubeSat. Now CubeSat's becoming much bigger and having more capabilities, including computing power. Because there's one finite element that we have. And I'm not talking about orbits here at the moment. I'm talking about spectrum and frequency, how to get the data down. As more data as we produce, we will have these pipes that we can't get data down. So I think that is a solution to optimize this transport stream. Am I correct with my assessment? Or
Thank you for this. I was not thinking about that. Yes, there may be an angle, because I mentioned the first layer of customer, but the second layer are satellite operators. right? So what they do today, they use as much as possible the download capability that they have from their satellite. But typically, commercial satellite can download between 40 and 70% of the data that generates. Institutional satellites, they reach 90%. But there is still a lot of data that is not coming to Earth, and they simply can't. So I said, what if you use the secondary communication system, you shoot them to me.
By capacity or by bandwidth capacity? That's a limiting factor.
Yeah, in some case they said, we don't want to spend too much money on ground stations, or we don't have bandwidth capacity. It really depends. But if you start in this way, just give me what you are not using. I will process for you. You will avoid to use like the frequency license and so on, use only what you have online. So we need also, by the way, this new regulatory framework that we will need. So at that point, whatever I'm able to do for you, it's on top of your business. But in the future, we will end up, as you said, on ground, right? So now I'm using the cloud to do most of the computational work for my design engineering team, right? So this is going to happen anyway. And the third layer is myself, first of all, in-orbit servicing. Imagine the complexity of in-orbit servicing. You need a lot of calculations, and you don't really want to do it by hand. And when you have 100 vehicles in orbit, how do you do that? If you have a cloud, then the cloud will do most of the work. You don't have to increase the computational power, energy, more mass, more cost. You delegate to a cloud, and then you keep computational power, minimum autonomy inside the vehicle to do the operations.
One element in this entire equation we shouldn't leave out of scope here, and that's the ground stations. The availability of ground stations at the time when you need it with their antennas and so on. And I think that fits perfectly into this vision.
You know what is happening now? That the ground station provider, at least some of them that we are using, they are already moving the concept of ground station from Earth to orbit.
Okay, yeah, exactly.
Right? So this is happening. Yeah. And there are other players like Kepler that is providing a piece of this cloud anyway, and they are already active. So they said, okay, you don't have the chance of downloading your information. Give it to me, I bounce it back, and I will bring you down for you. So at a very affordable cost. So there are a lot of new players that are connecting, because the cloud computing is not a monopoly. It should be as much as possible distributed. So we need to enable everybody to be able to be part of the network.
So how far are we away from this data center in network, in space?
Very good question. If you analyze how the cloud came for us here on Earth, let's say Amazon, right? So Amazon start building the servers for completely different purpose, because they need the servers for themselves. Then they realize, oh, wow, we can make money if we sell a service on top of that. But the cloud service itself, it's hard to close the economic loop if you consider the investment in the infrastructure. So it means that you need to separate the infrastructure from the service, at least at the beginning. So if you just now say, oh, Luca, would you invest, 200, 300 million to build all the satellites? I said, I can do that, but then I will, the break-even is going to be a very long time. So we need to consider the infrastructure as an highway. So that either a customer will pay for the highway and then I take care of delivering the service, or if I have to do it by myself, what I can do, every time that I launch one of my satellites, I spend some more money to adapt the satellite to become a node, but then at the end of the mission, I have an additional node. Of course, it's slower, so you have the faster and the slower. That's a good partnership with governments, for example. Right? So governments build the highways, and then companies will manage the highways. So this is a very good partnership, and now with the ministerial in Europe, this is hopefully going to be a big thing.
Okay. Let's take a moment in the various industries and how to bridge this industry. So more non-space industries, finance, insurance, cyber, smart cities are eyeing space for obvious reasons. So how can the Orbit Space Cloud Services connect these worlds? Because it's an uncharted territory for us in the space industry to talk to people outside the space industry and try to speak their voice.
Yeah. So you mentioned cyber, I'm coming back to that. But let's say, I think that the enabling machine to machine, it's going to be key. Most of the work we do every day, it's the human aspect. It's just a piece. Now machines are doing pretty much everything, but we are still using satellites to people rather than satellites to machine. So with the cloud computing network that can communicate everywhere and can pass the information from one node to another very fast, this is going to become not only possible, but improved a lot. Of course, you will need to improve the technology, and improving technology, it's something that will happen anyway. It's how you use the technology that change. Cybersecurity is going to be a major point. So, we have like in the Orbit, we say that we have the pillars of the space economy in our view. That is, of course, transportation of goods, transportation of information, transportation of energy, and cybersecurity, because everything is becoming software. My satellites are mainly software. I can reconfigure a satellite in orbit like even now, right? So that means that they are also vulnerable. And if we expand at the interplanetary level, this is going to be one of the biggest criticality. So we need to solve it now. What we use in space, it's not sufficient, and we need to evolve in that sense. So this is going to be a criticality, and we will need more companies from like cybersecurity world on Earth to look at space. Even if today it's a small market, it's going to be a very big market in the future.
I found it very interesting that you said when we are on the interplanetary path, then cybersecurity will become an issue. What we have seen over the last days here on the other side at the Space Defense and Security Summit is that it's now, it's not then, because on Ukrainian war, how this started with an attack to satellites and to infrastructure, so cyber attacks, this hybrid warfare is not something just in science fiction movies. No, it is there. And I think that's frightening. So cybersecurity is something it's not a nice to have, it's a necessity today.
So I totally agree. It is a necessity already today. What I was referring to, if you think to expand an interplanetary level, there's no way you can do it if you don't have this in place. But yes, totally agree that it's already a service that we need deployed as soon as possible.
Let's talk about partnerships, ecosystem. Innovation needs collaboration. I'm just put it out as a statement. You can say it doesn't make sense because we innovate in-house. But I would say it needs collaborations because you have the input from the outside. So how important are these partnerships with agencies, institutions, and private companies for staying competitive in such a global market? And you are this European unicorn that I want to repeat. So you are a European company with your facilities in the US as well. But you are from the core European.
Yeah, the roles are going to be different on the three categories that you mentioned. So let's start with the commercial company. So yes, it's true. We have quite a strong verticalization approach. But in reality, all these new startups have like amazing ideas, like products that can become part of my supply chain, or maybe they can become my customers. So actually, I'm very interested in what they do and to support them. The issue that they typically have, it's the time to market, right? So because in the space, if you don't validate the technology in orbit, then you cannot sell it. We have this program, so we help these companies to get up and test their technologies as soon as possible. The point is that I don't have like a lot of capacity, so I have to select the companies, and I have to be a little bit egoistic. So I choose the companies that can be my supply chain or potential customers.
But you're also a mentor in the CDL program. You see these already pre-selected companies on a silver plate.
Yes, and they are very good, amazing. And sometimes, for example, something that we are not doing, and I wish that someone else would start doing, it's the transferring energy from space to space, right? Because that's, why should I bring a lot of solar panels when someone else can power him up, right? So that's the idea. And at CDL, for example, there were like companies with good technologies in a market that was not fitting well, and they start working on this concept. So this is what we can do to support these companies, to accelerate the go-to-market, and sometimes provide some ideas. They say, you are smaller, like you are faster, go and try. Government, it's an agency, let's say, two different aspects and completely different. So I think they need to change their role from those that actually, let's say the agencies, those that actually send you the requirements, to those that actually enable you to provide a service. And in US, it's happening faster. In Europe, for example, the European Space Agency has an advisory group now. It's called New Space Advisory Group, but it's still slow to get implemented. I think the real barrier is like the middle managers. It's as in every company, right? So from the top, that's okay. Yes, very good idea. It's going to take time, but it's happening. This change is fundamental. As I said before, if you want to sell, let's say the toll service on the highway, it's a very good idea. You can grow a company, have a lot of benefits on the society, but then you need someone that is going to help you to build the highway, right? So that's the role of the agency and the government as well. And the government, I think, what they can do to accelerate innovation, it's instead of trusting only the big boys, they should look at the younger boys. And that's in US again, the mentality is different. But in Europe, if you are young and born yesterday, your value, it's almost zero. We need to change that because this will enable also for the government to have better technology, faster, and start a cycle of innovation that will become self-sustainable.
How is Italy doing in that matter? Because the Italian space agency, ASI, transformed over the last years. And from what I see from my end, in a positive direction. So how do you see that from the Italian side? Because they are your counterpart.
Yeah. So I have to say, so we were talking before about mistakes. Well, one of the biggest mistakes I ever made, the first time I met the Italian space agencies was 2011. I remember that I got out of the meeting saying, I will never work with the government in my entire life. That was a mistake. It took several years to invest in the government business. Yes, we are seeing this transformation. It's slow, but it's happening. Actually, I have to say, faster than I was expecting. We are not there yet, but the people inside, they are doing whatever they can in order to accelerate the profit. The issue is that the problem of public servant, so they get no incentive when they do well, but if they do a mistake, everybody will blame them. So why should they take risks? So it's very difficult for them. They operate in a very strict and firm regulatory framework that doesn't give you a lot of flexibility, but some of them, there are the changers in those organizations, are taking this risk and pushing back and like this framework, and that's what is changing in the organization. So Italy, it's moving, the direction is very good, and even the orbit is now working better, and we are learning. So they are learning from us, we are learning from them.
So next step is then ESA. But we have, as you mentioned, the ESA ministerial ahead of us, and so new and good things will happen. So finally, what's next for the orbit? So what milestones or breakthroughs can the industry expect from you in the near future? Open a bit the book of secrets.
So let's say that the big target that we had, the big objective that we set last year was to restructure entirely the company from inside, because we went from 60 people to 600 in no time. And basically what was working when you have 60 people and you just stand, go to the other desk, say, oh, look, let's solve this problem, was not working anymore. Decision-making process were not working, and then so on. So we say, okay, guys, stop. Let's not fix it. Because when you fix it, you put a patch, but the problem is still there. So let's not fix it. Let's rebuild it from zero. So we basically start from zero, a new organization. Now it's ready. It's going to start from January. So we will need more people, better process. And of course, this is not going to work 100% perfectly. So there will still be issues. So that's the big chance, because it's not anymore a matter of getting customers and getting traction in the market, also because the market is growing a lot. But if you are not able to sustain the growth, then you collapse. And that's something that we don't want to do. This is now happening. The next step in terms of growth, we will keep expanding.
Still need people?
I tell you, in the last 2 years, 99.0% of the bid, no bid, like process that we run in the company, we said no, because we don't have the internal resource to do that. In some cases, not even to bid. Right? So now we are taking care of that using some like AI tools, like to optimize the work of the people. We want to extract the brain from the people and challenge them. So yes, more people, expansion in other areas. And then let's see, definitely we have an M&A plan. So 2026, we start exploring also additional acquisitions.
So then to our listeners that are listening to our conversation here, the orbit is looking for new talented people. So in Italy or worldwide potentially, or?
Yeah. So in Italy, we produce satellites. In UK, we manage the cloud computing. In Portugal, cybersecurity. And in US, satellite bus. So they can pick the side that and by the way, in Bari, we do AI, machine learning, and downstream. So
in Bari, isn't that?
In Bari, in Italy, yes. It's Planetech, the company that we acquired.
But it's also in vacation destination for many Germans, I think. Yeah.
We like to say that the orbit has locations in the best beaches on the planet, and we will keep working on this trend. We'll open offices in the nice place. Yeah.
Wonderful. Luca, thank you very much for your time. I know you have a very busy schedule, but I'm very grateful that we up here today. And with that, SpaceWatch out.
Thank you. Thank you.
If you like these or other episodes of Space Café Radio, leave us a rating on your preferred podcast platform. It is the currency of today. And if you want to stay on the pulse of the space industry, please visit our website at www.SpaceWatch.Global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Thorsten Kriening, publisher at SpaceWatch.Global, your independent perspective on space.